The next question is May 2008, question 1. Again, it's a capacitor question, and it's from A2physics 5. An uncharged capacitor C1 of capacitance 200 microfarads is connected in series with a resistor of value 470 kilo ohms. A 1.5 volt cell and a switch S is shown in figure 1.1. The switch is closed and the capacitor is charged. On figure 1.2, sketch a graph to show the variation of energy stored in the capacitor with voltage V as the capacitor is charged. So if you just write down your equation, E is equal to half CV squared, therefore E is proportional to V squared, and if you were plotting a graph of E versus V, then it's going to be a curve which slopes upwards, like that. Next part of the question, part 2, calculate the maximum energy stored in the fully charged capacitor. So we're going to use E is equal to a half CV squared, and that's a half times C is 200 microfarads, and V is 1.5, and that's obviously squared, and that gives you 2.25 by 10 to the minus 4 joules. It's 2.25 by 10 to the minus 4 joules. And again, there's 3 significant figures, and the numbers in the question have 3 significant figures in them too. Next part of the question, the switch S is now opened, and a second uncharged capacitor C2 of value 400 microfarads is connected in figure 1.1. So really, this is just your capacitor, which is charged, sharing its charge with the second capacitor C2. Calculate the voltage across a combination of capacitors after they've been opened or joined, and the switch is still open. And so again, what you have to do is use the total charge, which we haven't calculated yet. So the total charge is charge stored on the 200 microfarad capacitor when it was connected to the 1.5 volts, and so that is equal to rearrange that, just right at the side. C is equal to Q over V, therefore Q is equal to CV. And so that's going to be equal to the 200 microfarad capacitor multiplied by the voltage 1.5, which is 300 microcoulombs. The total capacitance then, the two capacitors are in parallel with each other, and therefore you just add them. So it's 200 plus 400 gives you 600 microfarads, and therefore V is just equal to Q over C, which is 300 by 10 to the minus 6 over 600 by 10 to the minus 6, and the answer then is half a volt. The answer comes out to be half a volt. Calculate the total energy stored in the combination of capacitors, and so E is equal to a half CV squared, and you use the totals. So the total capacitance we worked out a minute ago to be 600 microfarads, and the voltage is half, and it has to be squared, and that gives you an answer of 7.5 by 10 to the minus 5 joules. And then part C of the question, the answers to A part 2, and I'm just write this down just to remind you. A part 2, the original maximum energy in the fully charged single capacitor was 2.25 by 10 to the minus 4 joules. And then B part 2, the answer came out as 7.5 by 10 to the minus 5 joules, which is less. Should show that the two answers should show that the energy stored in the combination is considerably less than that originally stored in capacitor C1 alone. Explain this difference in energy. So you can say something about the fact that there's a large transfer of energy, transfer of charge, should I say, and again that causes heat loss in the wires. And that's your 2 marks there.